Today's tutorial, I'm going to talk about different types of cell addressing as well as the fill handle in spreadsheets. This will work for Google Sheets or Excel. They're very similar. So let's get started. For the example, what I'm going to do is a multiplication table. So what we're going to have is up top here we're going to have an operand, and down here we're going to have an operand, and where they intersect will be the product. So to do that, I'm just going to type my data into the cell, and these are going to be integers. So I could type it in like that, but what's nice about spreadsheets is you can use the fill handle, which is this little box on the bottom of the cell, to automatically fill in a pattern. So if I just did this and I drag this across, it would fill everything with 1 because that's the pattern it recognizes. But if I had 2 consecutive boxes that incremented by 1 and then highlighted those by clicking and dragging, I can then use this fill handle to fill in that pattern, and it'll keep increasing by 1. For another example, if I had to increase by 4, for example, so 1 and then 5, and then I highlighted those, it would continue that pattern as well. I want to multiply, showing you every increment by 1 of the integers, so I'm just going to do 1 and 2 right here, and I'm going to make it to a range of 5. So 1, 2, 3, 4, 5, like that. Now my operands on this side will be the same. So it'll be 1 and then 2. Whoops, and then you can do the same thing here. If you hit enter, it'll go down 1 block automatically on your keyboard. So I'm going to continue this down to 5. So now I have my operands, and in the middle is where they're going to be the product. So if I did 1 times 1, it would be 1. But in spreadsheets, we can automate this stuff, and that's why we use spreadsheets. So instead, I'm going to put in a custom formula. And to do a formula, you can either do insert and then a function. But what I want to do is a custom formula, so actually I just hit equal sign. And then equal sign, you can type in any type of expression you want. Notice it shows you FX up here, and you can see it there as well. So I'm just going to escape for a minute and zoom in for you guys. So when I hit equal sign right here, I have it up here where I can type it as well. So what I want to do is the product, so I would do 1 times 1, and it gives me the product. And this would be 2 times 1. But what's nice about spreadsheets is we can use cell referencing. So we're just going to use variables in this case. So in this case, it's actually whatever's in this box. So I just click on the box, asterisk, that's the multiplication sign in spreadsheets, and then this box. So I want to multiply whatever's in this box by whatever's in this box. And I hit enter, and it will do it automatically. Now if I click this and then take that fill handle and drag it down, it'll copy that formula all the way across. However, you can see that these are not the correct answers because 1 times 5 is not 5. So what it does, it just copies the way it was and uses that template as it fills it in. So in the original example, it was multiplying the cell to the left times the cell to the top. So that's what it's doing here. But what I need to do is tell it to multiply the correct ones. Now I do want it to change as it goes to the right. I do want it to multiply the top cell, but I want it to always multiply cell A3. So I need to set it so that it does that. So what we've seen here is as it goes with it, this is called relative addressing. I need to use absolute addressing. So if I look at my original formula, if I put $signs in front of A and 3, it'll lock that cell in place, and that's called absolute addressing. So $A, $3. Now, if I drag this down and fill it, you'll see that it's always referencing A3. And what's nice is it's relative column wise, but it's always staying in the same row over here. So the first operand is always in column A, and the second operand is in the relative column on row 2. So now what I'm going to do is copy this down so I can get my whole table. But you can see that this is not correct either, because now what's happening, it's still multiplying by this one up here because it's absolute, and it's still referencing the one just above it, so that's not correct either. What I wanted to do now is be relative on this side and relative across. So I needed to stay in row 2 when it's going on the second operand, and I needed to stay in column A when it's going on the first operand. So to fix that, I need to use mixed addressing, so a little bit of relative and a little bit of absolute. So if I go here, I need the column to remain the same, but not the row. So what I can do is take the row off of absolute, and then the second operand, I need the row to remain the same. I always want to keep it on row 2, but I want the column to change with where I am. So in that case, I would make the row absolute. So this is called mixed addressing because now I have absolute and then relative and then absolute. And again, the absolute row for the second operand will be row 2, and the absolute column for the first operand will be column A. So now if I hit enter, you'll see the answer remains the same. If I bring this down, no change here. You can see it's still referencing the correct one. But if I highlight all this and then fill, now everything is correct. 5 times 5 is 25. And you can see it's referencing the right column and the right column with the correct row and correct row. So again, that's mixed addressing. So that's an overview of reference addressing, absolute addressing, and mixed addressing. And you just kind of figure out whatever you need for the application you're using, and you determine. But think about which row and column you want to remain isolated or stay the same basically as you're doing your calculations.